How's it going? It's your old pal, Mr. Cook, and we are working on the 7.2 extra practice. This is all just verifying trig identities, and it looks like the problems range, because of this little rating scale that we gave it, from 2-star problems, so kind of easy ones, to, yikes, some 5-star ones. So these might be a little bit more challenging as we see them. Okay, so let's work on some of these. We start off with some obvious cofunction identity problems because that we got that pi over 2 minus x. That should be like a easy giveaway that this is a cofunction identity. So we use our cofunction identity in the numerator and also in the denominator. And this turns into sine, cosine turns into sine of regular old x. Sine of pi over 2 minus x is a transformation, and the cofunction identity for that is just regular old cosine of x. And then this, oddly enough, goes directly into the tangent of x because that is a quotient identity. Sine over cosine, where is it? Sine over cosine is equal to tangent. So, it leads directly into there. So just a couple steps, and we're all done with that one. Nothing too difficult, and maybe the level of difficulty is just because of the, we use 3 identities kind of like right away to solve it. So second problem, looks like we have cosecant. And that looks like another cofunction identity, doesn't it? So cosecant, its cofunction is secant, because secant and cosecant are related. So the top part just turns into secant squared of x minus 1. And then the bottom part is still that same thing, sine of x, secant of x. There we go. So we're trying to turn this whole thing into tangent. I can see right away that like this top part, that's a Pythagorean identity, and it can turn into tangent squared. So, that's one thing that I would probably do for that. Like when you see an identity that's like that obvious, like this one is, exactly right on there. And especially if it leads into something that's related to something that you're trying to verify it to, it's a tangent, like, make that change. So this is a Pythagorean identity that turns into tangent squared. But we're somehow going to have to divide out a tangent from the bottom, so we got to manipulate this stuff a little bit. So let's see exactly what we're working with. I know that we got a sine of x and a secant. So this secant, I'm going to turn that into a sine and cosine kind of situation. So I'm going to use the reciprocal identity for secant because that can help me to turn that into a cosine just with one short step. So we've got sine of x, and then secant turns into 1 over cosine. Okay, next I'm just going to multiply these two things together. So I get tangent squared of x over, and then it's going to be sine of x over cosine of x. And sine of x over cosine of x should look familiar because we just used it like a second ago. It's a quotient identity, and that turns into tangent of x. So we are really cooking with this one. So we got tangent squared of x over, and then this is a quotient identity, and that turns into tangent of x. So then we have a tangent squared in the top, tangent squared in the bottom. One of the tangents cancels out from the numerator and denominator, leaving us with our desired conclusion on the right-hand side, tangent of x. So this solves the second one. So this is probably a 3-star one just because of the, again, the number of identities, and then also kind of just recognizing that it'll cancel out pretty easily. And I guess also hesitating to turn that into sines and cosines is just recognizing the Pythagorean identity there. Anyways, let's move on to the third one, actually. Third one is a 2-star problem, so let's practice through that one. I've got a secant and a cosine, a tangent and a cotangent. Like, what's really enticing, okay, so you kind of want to turn these into sines and cosines because of the diversity of the ratios that we're using, the different trig functions, but like, if you look closely, secant and cosine are reciprocals of each other. They're reciprocal identity, reciprocals of each other. Same thing with the tangent and cotangent, right? So I'd hesitate to turn those into sines and cosines. What I do instead is just kind of separate them. Because how like if you have a fraction, if you have like x over 2, you can turn that into x times 1/2. I'm going to do the same thing with these fractions and just evaluate it from there. So I have secant over cosine. That's the same as saying the secant of x times 1 over the cosine of x. Right, just using that same kind of rule. And then I'll do the same thing here. So I've got the tangent of x, and then times 1 over the cotangent of x. So I hesitated for a second to turn these into sines and cosines, and by doing that, I helped myself out a lot because, going back to the reciprocal identities, I know that 1 over cosine is secant. So I can turn this into another secant using a reciprocal identity. And same thing with the cotangent. The cotangent, 1 over cotangent, is tangent. So this just turns into tangent, so another reciprocal identity. So let's see how that would look. I'd have the secant of x times the secant of x minus the tangent of x times the tangent of x. And then I'm trying to turn this into 1, and some of you might see it already, like, if I have secant squared minus tangent squared, that's going to turn into 1, and that's what I'm going to have here in a second. So when I multiply this stuff together, I get secant squared of x minus tangent squared of x, and that is my Pythagorean identity, and it just turns into 1 there. So circle that one, that's a Pythagorean identity, and we get 1, which is our desired result that we want. Okay, so moving on, number 4, another 2-star problem. We've got cosecant squared times tangent squared minus 1 is equal to tangent squared. Okay, well, I mean, I've got some squared stuff, minus 1 equals tangent squared. Let's go back over those Pythagorean identities. So I see that I've got a tangent squared, and I've got a minus 1. So is it possible that this is just secant squared? Let's find out. So let's kind of evaluate this part of it. Let's turn these into sines and cosines. So using a reciprocal identity on cosecant, I get 1 over sine squared. And then with tangent, if I use the quotient identity, I get sine squared over cosine squared, then minus 1. So as you can see, when these multiply together, the sine squareds cancel out, and I just get 1 over cosine squared of x minus 1. And, 1 over cosine is secant, so 1 over cosine squared is secant squared of x. And just like I saw before, secant squared minus 1, that's a Pythagorean identity. And that's obviously equal to tangent squared, which is our answer that we were looking for in the first place. So that's number 4, another 2-star problem. Let's let's work through these a little faster, because the 3 and 2-star ones aren't terribly challenging. So, let's just kind of see what we got, working through them. Hopefully it's not a ton of work that we need to do. And I'll even, I'll try and do some shortcut things here, but I think just to kind of open it up, I'm just going to do more or less the same steps for these ones on this page, and just do sines and cosines for everything. Just to see what it is, not to really use my brain too much, and just concentrate on the arithmetic afterwards. So I've got my secant, so that's a reciprocal identity to turn that into 1 over cosine times sine. And then the denominator, and then the tangent, that's going to be a quotient identity, and that turns into sine of x over cosine of x. And then plus, and then I've got another cotangent, so that's going to be quotient identity, and that's cosine of x over sine of x. Okay, so I multiply this stuff together in the top, and I get sine of x over cosine of x. And then let's do the common denominator, I guess, there. So I multiply the top and the bottom by sine squared, and I get sine squared of x over sine cosine. Yeah, sine cosine. And then this one, if I multiply the top and the bottom by cosine squared, I get plus cosine squared of x. So now I've got my common denominator, and I've got my 1 fraction as well. So this is a Pythagorean identity, sine squared plus cosine squared, that's just 1. So I'm just going to rewrite that. So Pythagorean identity, and I get sine of x over cosine of x over, and then it's 1 over sine of x cosine of x. Then this is a fraction over a fraction, so it's the same as multiplying by the reciprocal of the denominator. So I've got sine of x over cosine of x, and then times sine of x cosine of x over 1. Multiplying straight across, let's see what cancels. The cosines cancel out, so that just leaves me with sine squared, which is what I was looking for in the first place. That solves that one. There's probably easier ways to do it. Let's think. Yeah, I bet you could do probably an easier way. I don't know. I'll just do the sines and the cosines just to start it off. These already are sines and cosines, so the easiest way to work through this one is, since I have a fraction minus a fraction, find the common denominator and then combine it into a single fraction. So I've already got sines on both of these, so all I got to do is get a cosine on this denominator. So I'm going to multiply the top and the bottom by, cosine. So I get 1 over sine of x cosine of x minus, and then it'd be cosine of x over sine of x times cosine of x over cosine of x. That will give me my common denominator. And let's see what we end up with. So we get 1 minus cosine squared of x over sine of x, cosine of x. And 1 minus cosine of x, that's a Pythagorean identity. That turns it into sine squared over sine of x, cosine of x. One of the sine of x's cancel out there, so we get sine of x over cosine of x. And then that's a quotient identity, and that's just tangent of x. And that's what we were looking for, tangent of x in the first place. Okay, 7. What do we got here? Sine, cosine, cotangent. So cotangent is the only one that's not in terms of sine and cosine, so I'm going to use quotient identity and turn that into sine of x plus cosine of x, and then that would be cosine of x over sine of x. Okay, and then let's see here. This turns into sine of x plus cosine of x squared over sine of x. So I've got a fraction plus a sine of x. Let's find the common denominator here and then turn it into one fraction. So I multiply this by the sine of x over the sine of x. And then I get sine squared of x over sine plus cosine squared of x over sine. Combining them together, I get sine squared of x plus cosine squared of x, which is our granddaddy Pythagorean identity. So that just turns into 1 over sine of x, and obviously that one turns into the result we were looking for in the first place, cosecant. So cosecant of x would be our answer there. Oh yeah, oops, got to circle that and say reciprocal identity. Almost didn't label my step that I made. Okay, and then the last of our little 3-star ones, because after that it's the big boy problems, 4 and 5-star problems. So let's work through this one, I guess. Let's, we've been doing the same stuff, so let's just do sines and cosines again and see where it takes us. So that's a reciprocal identity. These two are quotient identities. And we're supposed to turn this whole thing into cosine. So cosecant is 1 over sine. Tangent is sine over cosine. And cotangent is cosine over sine. All right, let's get the common denominator on the bottom there. So we got 1 over sine of x over. Now if I multiply the top and the bottom by sine, I get sine squared of x over cosine sine, or sine of x, cosine of x. And then I'm going to get the same denominator here because, sine times cosine. So let's just turn that into one big fraction. And then plus cosine times cosine, which is cosine squared. So this all seems really familiar because it's something that we did in, which one was it? Yeah, it's a lot like 5 from here on out, it looks like. Just the only difference is the numerator, but it's real similar. So the same kind of steps as before. This is a Pythagorean identity, so this turns into 1 over sine of x over, and then it'd be 1 over sine of x, cosine of x. And then we multiply by the reciprocal, so we get sine of x cosine of x over 1 times the 1 over sine of x. So obviously the sine of x's will cancel out there, and we just are left with our answer, cosine of x. So that's kind of an easy way to do it, I guess, just sines and cosines. Okay, that's the end of the first page. So these were the 2 and 3-star problems. Yeah, and let's move on to the next one, which is a little bit of a step up in difficulty.